So, Vyom, thank you for coming on the show. Can you tell us a little bit about you and how you are involved in the CNCF?
Hey everyone, my name is Vyom and I've been involved in CNCF for the past 3 years. I actually started contributing to CNCF in the sophomore year in college. I started with an admission controller called Kyverno, did my LFX internship with them, and then I proceeded to contribute to Kubernetes upstream. I've been involved in the Kubernetes release team since V 1.27, so it's like what, 7, 8 odd releases till V 1.34, and I'm also a CNCF ambassador. So been involved for quite some time, and I also work as a security engineer at Canonical.
Great. Thank you for being here today. So, can you tell us what are you the most excited about when it comes to this new release of 1.34?
Well, there are a couple of features, and I cannot just pinpoint one feature out of the whole release. There are like 58 odd enhancements in the release. But there are a couple of features that caught my attention, especially because I work in security. So there were a couple of security related caps that caught my attention. So I'd start with a cap called projected service account tokens, which basically allows you to have pod identity level based tokens for pulling images from a private registry. So if you're not familiar with this concept, there are two ways of actually fetching images from a private registry. Either you create image pool secret in your Kubernetes cluster, or you have credential provider config, which is node level image registry access provider. So this really does not allow you to have pod level identity for accessing private registries. So what this cap allows you to do is it allows you to specify the audience in the credential provider config, and you can have service account tokens actually matching on those audiences so that only a particular service account or only a particular pod identity can fetch an image from private registry. So this is great for multi-tenant clusters in which you have now better isolation and there is no over access of image registries or image registries at a node level in any other pod can access which is running on that node. So I think it's a great enhancement towards security. And yeah, there are a couple other enhancements as well.
Amazing. We'll stick to security. Can you let us know about what was improved when it comes to admission policies?
Yeah, admission policies. So I worked with admission controllers, and at this time, all this discussion was happening, and validating admission policies were new into Kubernetes. So now Kubernetes has moved on to mutating admission policies. So during your admission control, now you can actually modify the incoming object to the API server according to the policies that you have set up in your cluster. I think this is great. It reduces the overhead of actually managing and scaling an external admission controller like OPA or Kyverno. Those are great tools that support a lot of other features, but for the use case of just having mutating admission control over resources, I think this is a great feature. And if your use cases for admission control are right now limited to validating and mutating, you can actually just use what Kubernetes comes with out of the box instead of having to manage external things. So great feature, and if this solves your use case, I think cluster admin should give it a try.
Is this leveraging the CEL, the Common Expression Language?
Right, yes. So both validating admission policies and mutating admission policies leverage cell. I think cell has kind of become a de facto for filtering out on objects and expressions across Kubernetes. There's another great feature, I think, which we'll cover later, DRA going GA, the big thing. DRA also uses common expression language or cell. So it's kind of becoming a standard across the Kubernetes ecosystem.
Okay, all right. So I have my bridge for the next point I wanted to discuss today. Obviously, GPU is GPU workload are rising, skyrocketing on Kubernetes, and obviously all these great workloads are often powered by Kubernetes. So as you mentioned, DRA is going GA. Obviously, that's not something new. but it proves that like Kubernetes is definitely becoming a de facto and stable platform to run this type of workload. Can you remind the audience what this is about and what is GA bringing to the table?
Yeah, DRA going GA, this is actually one of the big highlights of this release. And of course, if a feature is going GA, there won't be many feature additions to the core of that thing because beta is expected to be decently stable. But DRA going GA is actually a big milestone for the ecosystem and for the CAP itself. So DRA going GA actually gives you better support for sharing resources like GPU across different pods or containers in your cluster, which wasn't really possible earlier with the device plugin API. It allows you to have simple allocation of devices to pods based on conditions written in cell. So it's really easy for cluster administrators to and cluster policy writers or whoever is actually creating pods that get bound to nodes which have access to devices. It makes it really easy for them to kind of select devices and filter on expressions which were not supported earlier by the device plugin API. And this particular cap also allows for cluster autoscaling, which the earlier implementation of DRA did not support. So I think this kept going stable. It has been through its kind of highs and lows. For those of you that don't know, there was an older implementation of DRA, which did not really allow cluster autoscaling. So now it has gone through its kind of lows and considered all the real world use cases and combine that together to ship what we are calling DRA as GA now. So I think it's a really great step for GPUs, NICs, FPGAs, or any kind of device you want to attach to your Kubernetes cluster.
Around like GPU and acceleration, and is there any other features that you are working on or that the community is looking to get that is in the pipe or the community is looking at building that you could share with us today?
Yeah, so DRA going GA is just one of the caps in this particular release. There are quite a lot of caps related to DRA in this release as well. One of them actually allows you to have priority lists in which you want to select your resource. For example, if I want to select a beefy GPU, what if that GPU is not available? Can my workload really suffice with two smaller GPUs? So things like these are there in this Kubernetes release, and there are a lot of other caps around security in DRA. So DRA going GA is just the core of DRA going stable, and a lot of development around DRA is still happening in Kubernetes, and there are beta and alpha features in this Kubernetes release regarding that.
All right, switching gears. Um, the API server got a revamp. Can you brief us on this?
Oh yeah, this is actually a pretty interesting cap, and a few fellow contributors I know actually worked on this. So this is actually a trifecta of caps. This is not a standalone cap. So the API server's performance improvement started when it was consistent reads from cache. I think this is going stable, I believe, this cycle. The numbers are a bit hazy right now, but what this cap basically allowed you to do is that earlier, any request to the Kubernetes API server could bypass the watch cache of the Kube API server, which meant fetching resources directly from etcd. And on etcd level, you don't really have filtering based on expression. So if I want to have a pod selector for particular label and list those resources, etcd directly can't do that. It can basically just filter based on namespaces. So imagine if I have to fetch a resource which is like label foo, I would have to fetch all the resources in that namespace or all the pods in that namespace, and then the Kube API server would basically filter it out. So with this enhancement, which is consistent reads from cache, this basically allows you to have filtered expressions, and it reads from the watch cache instead of reading from the etcd directly. And it does that using something called as progress notifications that was built by the etcd team. So this is a collaboration between the etcd team and the Kubernetes folks. They work hand in hand to kind of support this. This was the first cap of this trifecta. The second one was actually streaming list responses. So if you're listing anything from the Kubernetes API server, what used to happen prior to this was all of them, all of the list responses were buffered into memory, and then they were sent out to the user. So now this created a memory spike in your system. So to prevent that, now we're gonna streaming responses. So a connection is gonna live for some time and it's gonna stream the responses to the client. So this was the second thing in this trifecta. And the third and the major thing that is in this cycle, which is snapshotable API server cache, but this allows you to actually use the same wash cache for historical requests. So if you want to list resources for a previous resource version, what happened is that those requests went to etcd directly, and any request going to etcd means that there's going to be a performance lag. So now there's a clever implementation using B trees in which it's basically storing pointers to previous states, so that now even the historical list requests coming to the Kubernetes API server can be served from the watch cache. So this is a really great performance improvement for the Kubernetes API server. And this kind of KEP, which is merged in this release, which is snapshotable API server cache, kind of completes this trifecta and is a major milestone for API machinery and etcd folks.
All of these are amazing improvement. I'm sure the community and the listener will be like very excited to try those. Vyom, if people want to get in touch with you or read about your work, where can they find you on the internet?
I'm not really that active on social media, but you can find me on LinkedIn. You can technically find me on Twitter or X as well. I'm not there on Blue Sky yet, not a social media guy, but you can find me on the Kubernetes Slack. I'm pretty active there, and it's usually running. Slack is usually running in background in my computer, so it's most likely that you're gonna get responses from me earliest on Slack. So join the Kubernetes Slack, get your invitation, and if you have any questions, ping me.
Super. Thank you for coming on the show.
Thank you for having me.